So here on Let's Talk Bitcoin, we like to talk about complicated issues in understandable terms. And that's something actually we've kind of stopped saying on the show because it sort of became a thing we said all the time. But here, I think it's particularly applicable. Gavin Andreessen, the lead developer on the Bitcoin project, put up a blog post on the Foundation's site called Core Development Update Number 5 that basically goes over everything that's coming in the Client 0.9 update. That update isn't out yet. It's going to be out, it sounds like, in the next couple of months. I don't think we have a firm date on it, but there's lots of stuff that's changing and lots of stuff that's happening in this update. And I think it's really important that we address this and break it down point by point. As always, I'm joined by Andreas M. Antonopoulos and Dr. Stephanie Murphy. Hi, guys.
Hello.
Hi.
We're going to jump right into this. This is straight from the blog post. We're going to go through this point by point and talk about each of the issues as they come up and kind of get a feeling for what's going to change in this coming major update. From the article, since my last update at the end of June, the core development team produced 2 minor bug fixes while working towards a major 0.9 release. We've reviewed and closed over 300 pull requests, which range from correcting the spelling of a word in a comment to major new features like the payment protocol. I'll highlight some changes that are already in the 0.9 source tree and then write briefly about some changes that we hope will be ready soon. The first change that they talk about is provably prunable outputs. Quote, there have been huge debates in the past about embedding data in the blockchain. Some people feel like the blockchain should be a public resource available to use for whatever people like as long as they pay sufficient transaction fees to make it worthwhile for miners to store their transactions. Others feel that the blockchain should only contain the data necessary to validate Bitcoin transactions and any other data should be stored separately. While the debate raged, clever people found a lot of ways of embedding data in the blockchain. So with some reluctance, and again, this is Gavin, recently merged pull request number 2738, quote, relay OP_return data TX out as a standard transaction type. The idea is to give people a way to do what they clearly want to do, associate extra data with a transaction that's secured by the blockchain, but do it in a responsible way that strikes a balance between you can put whatever you want in the blockchain and you'll have to be tricky and inefficient to get your data into the blockchain. Pull request 2738 let developers associate up to 80 bytes of arbitrary data with their transaction by adding an extra, quote, immediately prunable zero value output. So let's stop there for a second and talk about what this means. Basically, there are lots of uses out there, be it from using the blockchain as a notary and storing the hashes of like a contract that you signed in the blockchain, or sending messages, or we've even had people storing kind of illicit information. We talked about inappropriate links and things like that being put into the blockchain as a way of distributing it without associating legal liability.
Gavin really talks about provably prunable outputs, and it's a bit confusing because it's not clear what prunable outputs have to do with putting data in the blockchain. So let me very briefly explain this. Because there wasn't an official mechanism for putting data in the blockchain, people created fake transactions. And these transactions were to addresses that don't exist. So instead of, paying Bob at the coffee shop for your coffee and sending it to Bob's address, if someone's trying to use it for a notarization service, they send a tiny payment to a bogus address. And this bogus address is basically an unspendable output because it can't be used in a subsequent transaction to redeem that money because there is no key. It's not a real transaction. There's no way to unlock it. Effectively, the key that's supposed to unlock it is the data that you're trying to stick in the blockchain. It doesn't work as a key. It only works as a block of data that you put in there. The problem with this is that because you have to keep all of the possibly spendable outputs in a database in order to figure out if you can create a new transaction, what that does is every time someone notarizes something, it puts a transaction in there that's going to stay in the blockchain forever and will never be excluded from the pool of transactions because you don't know if it can be spent or not. It looks like a normal transaction. This solution is to create a transaction specifically for putting data, and because you know it's for data, and because you know it can never be spent, and because you know it doesn't have any value, only fees, then you can just basically discard it. The only nodes that need to keep that are nodes that are interested in keeping a full archival copy of the blockchain. It's no longer needed for normal operation and spending. So this is a great compromise. It gives us an official way of putting data in the blockchain without burdening it with fake transactions that we have to carry forever just in case they might be spendable.
Let me interrupt you for a minute though, Andreas. Up until this update gets made, any notary type data that's in the blockchain is going to stay in the blockchain. Is that right? Or can it be retroactively pruned out?
No, all of the junk that's in there is in there and will remain in there, but it's really not a problem at today's scale because all of these things are tiny and nascent services. So, you know, a far bigger problem was the use of unspendable outputs to signal the results of gambling on specific sites. And that was creating dust, as it was called, you know, microtransactions that are not spendable. In fact, most of that came from just a few gambling sites. This actually solves that problem too, because now you can send back a transaction that says that you won or you lost without it being a fake transaction.
So does this mean that the rate of growth of the blockchain is going to slow, perhaps?
Not really. The size of this new thing is about the same as the size of the old transactions. It's not really that different. So it's not going to make an appreciable difference in the growth of the blockchain. What it will do, however, is it will allow you to create nodes that are full nodes in terms of transactions, but don't have a full copy of every unspendable output because they can just ignore things that are not payable transactions. So you can separate the stuff that's in the blockchain from money from the stuff that's in the blockchain as information content. And some nodes can choose not to carry the information content or not to remember it or not to keep it in memory. So it gives them a way to differentiate.
But there's still going to have to be some like amount of nodes that are dedicated to remembering this information though, right? Because
Correct.
It seems like there could be a risk of it becoming too centralized, right? Like if only one person has the notarized copy that Stephanie bought a house on this date with Bitcoin, that might be a problem. But if 100,000 people have that, then it's probably okay, right?
Well, actually, no, because these transactions will still be mined. They'll still be propagated across the network. They'll still have proof of work and they'll still have the same security. The full blockchain will include everything. The only question is whether in the in-memory database of spendable transactions you keep in a wallet application or in a payment application, whether you have to keep these things. So essentially it creates two types of full nodes. Those are the transaction focused and those that are more archival focused and just keep a full copy of the blockchain for archival purposes. I don't see it as a problem for centralization. All of this stuff will be in the blockchain. It will be mined and is just as secure as any other transaction.
Do you think this will change how people use the blockchain for things like notary purposes?
Oh, absolutely. It creates a really, really neat solution. Now you can create an output that is clearly for storing data. It's got enough space to do a SHA-512 hash. It has 80 bytes, so you can do a SHA-512 and have some room for some additional metadata. And you can then clearly identify these transactions and process them. So they're not just raw data, they're kind of structured. All of that really is going to make for much more efficient use of the blockchain as an information store. I expect all of the notarization services, as soon as this is widely available, to switch to implementing it because it's a much cleaner solution.
This is a service that's being offered to these people who want to embed information into the blockchain, but they don't actually have to change what they're doing, though, do they?
It's not a service.
The method they've been using will work.
The method they've been using will work. It will be less efficient and it's kludgy. But what this is a transaction operand in the transaction language that is used to build transactions. So if before you had, 12 verbs for building transactions, now you have 13 verbs for building transactions. And one of the exotic types of transactions you can build is kind of this data content transaction. Now keep in mind, the vast majority of transactions on the blockchain follow a very, very simple pattern, which is pay whoever has this public hash address. The vast majority are address A pays address B. But the transaction scripting language is much, much more sophisticated and complicated than that. And you can do a wide variety of things. So this gives people more language to use when creating transactions. So when they create these transactions, they can be explicit about them being data content rather than kludgy and building custom transactions that are faked.
So how would someone actually go about using this? Here's the next quote. The core code has no easy way of creating these new transaction outputs. You have to create them yourself using the raw transactions API. And there are no plans to display the data in Bitcoin QT, so you don't have to worry about someone sending you a few millibits and attaching a short but annoying message to the transaction.
This is no different from what we have today. I mean, none of these fake transactions can be created without having direct access to transaction API. Essentially, you hand code these with your own code to build these transactions. It's really not that hard. It's only about 3 lines of code to build a transaction like this in pretty much any language. There's no difference in those terms from what we had before. You still will need to build custom code to create these transactions. The only difference is that now you have the explicit verbs to do that and you're not faking it.
So the next section deals with auto tools. Reading from Gavin's blog post, less controversial, I hope, but more disruptive to core development, we've switched from using hand-coded platform-specific makefiles and QMake.
Basically, makefiles that are automatically generated with auto tools.
Yeah.
So Andreas, when they're talking about auto tools here, this is dealing with how they actually roll out new versions, right?
No, this is the build system. This is taking source code and converting it into binaries for all of the various platforms. You know, Bitcoin is a multi-platform source base, a single code base that compiles to multiple targets. You can take the same Bitcoin code and compile it for Windows, for OS X, for Linux, for, you know, a very wide variety of POSIX compatible operating systems. Up to now, each one of those had its own kind of custom. So if it's OS X version blah, do this. Now it's using auto tools, which probe each system. They use some heuristics to try to identify what type of system is, what capabilities it has, and then automatically generate the appropriate package. This matters for two reasons. One, it makes it much easier to keep the code base generic while simultaneously broadening the number of targets that this code can be deployed to. And two, it makes it a lot easier to run automated testing suites on the various builds. So for example, new code is released or a pull request is pulled in or a patch is pulled in, that immediately needs testing. So now you can run automated tools that not only test, say, the Linux version, which is the easiest, but you can also run testing on every version of Windows, every version of OS X, and do regression testing, etc. with those. So it makes it much easier to do automated builds and, more importantly, automated testing.
Andreas, could I think about this as like standardizing the way that the various clients are being built?
Yes, exactly. It's standardizing them to the most common build platform, which most POSIX operating systems support, and it makes it possible to vastly expand the targets. Yeah.
Also, as a standard user of Bitcoin, but not someone who really gets into the technical side, is this something that I actually need to care about?
No. But if you had to download the code and, say, compile it on Linux in order to use it, to test out Bitcoin Qt or run a Bitcoin daemon as a node, a full node on your Unix system or a hosted server, you'd have to compile Bitcoin. Now, up to now, that involved running QMake and a few other things, and it was a bit of a hit and miss thing, like, oh, it's not quite the version of Ubuntu, it has a slightly different version of this library, and then you have to fix all these dependencies. With this new system, you type 3 commands, autogen, configure, and make, and it would basically figure all that out and build it for you. And it makes that process a lot simpler and more standardized. Also makes it easier to package and include in various operating systems using the operating system standard package manager. So for example, in Linux, you might have RPMs for Red Hat, or you have deb packages for Ubuntu and Debian. On OS X, you have dpackage or DMG for archives for applications, and on Windows you have, you know, install shield exes or whatever they're using these days on Windows. So it allows you to essentially create automatic installers easier as well.
EasyDNS is the Swiss Army knife for your domain names, helping meet their customers' individual needs since 1998. EasyDNS has been an outspoken critic of SOPA and CISPA. EasyDNS was an early supporter of Bitcoin, and now they are proud to sponsor this show. Do business with a company that shares your values. Get a 13% discount when you pay with Bitcoin. Go to bitcoin.easydns.com and be sure to use discount code LTB.